Let's look at another example. We know that this is an exponential function because our variable is being held hostage in the exponent. Whenever your variable's in the exponent, you have an exponential function. Exponential functions immediately have a domain of all real numbers, negative infinity to positive infinity. Okay. Our horizontal asymptote is whatever is added or subtracted at the end, which means that we have a horizontal asymptote of y equal to -4. To calculate the y-intercept, remember that we plug in x equal to 0 because our y-intercept is in the form 0, some number. Plugging in, we're going to have 1/3 to the 0 minus 4. Remember, 1/3 to the 0, anything to the 0 is 1. Minus 4 gets us -3. So our y-intercept is 0, which we plugged in for x, comma, -3. Don't forget your parentheses around your ordered pair. Then we need to find 3 additional ordered pairs with at least one of them being negative. I'm going to write down our function again. Okay. Remembering the parentheses around the 1/3, and I'm going to set up my XY chart. And just so you can see what's going on, instead of 3, I'm going to plug in 4. So let's say that we decide to plug in 1, 2, -1, and -2, just to get our negatives in there. We're not plugging in 0 because we already did. That was our y-intercept. So if I'm plugging in x equal to 1, that means that I'm going to have 1/3 to the 1 minus 4. 1/3 to the 1 is 1/3 minus 4. When you get your answer, go ahead and convert it back to a fraction because this gets you -3.666 ... 7. We don't want the decimal. We need the exact answer. So -11 thirds, which means my ordered pair is 1, -11 thirds. If I plug in x equal to 2, I would have 1/3 to the second minus 4. 1/3 squared gets us 1/9 minus 4, which if you're getting the decimal, it's -3.888, so forth and so on. Repeating, but we need the fraction because that is our exact answer, which is -35 all over 9. So we have our ordered pair 2, -35 over 9. Notice that we're getting closer to -4. We went -3.6666667, -3.8888889. Let's figure out what happens when x is equal to -1. We would have 1/3 to the -1 minus 4. When you take 1/3 to the -1, that becomes 3 minus 4 gets us -1. So we have the ordered pair -1, -1. And then let's see what happens when x is equal to -2. we would have 1/3 to the -2 minus 4. 1/3 to the -2, if you take 1/3 to the -2 in your calculator, you should get 9 minus 4, which gets us 5. So we have the ordered pair -2, 5. Notice the more negative we get, the higher our y value. So again, let's go ahead and graph this so we can see what's going on. We have the ordered pair 0, -3, which was our y-intercept. We had 1, -11/3. And remember, -11/3 was -3.6666, so forth and so on. So a little bit more than 3.5. So 1 and then -3.5, roughly. At 2, we had 2, -3.888, so forth and so on. Really close to -4, but not quite. I'm not labeling those ordered pairs because that would take up my entire graph trying to write those fractions. When we looked at -1, we had -1. And when we looked at -2, we had 5. So -2 on up to 5. Okay. We also had a horizontal asymptote of y equal to -4. So at -4, I'm going to go ahead and do my dashed line. That's my y equal -4 horizontal asymptote. Now that I have that, I can connect my ordered pairs for my graph. If I start at my y-intercept 0, -3 and go to the left, my graph is going up. When I come to the right, we're getting smaller and smaller and closer to y equal to -4. Remember that it plummets down when your base, what has the exponent, is in between 0 and 1. So our range in interval notation, remember I told you it was going to be in two forms. It's either your horizontal asymptote, comma infinity, or -infinity to your horizontal asymptote. The first case is when your horizontal asymptote is your floor. And the second case is when your horizontal asymptote is your ceiling for your function. So when we go and look at our graph, the y equal to -4 is our floor. We're walking on it as our graph gets closer to y equal to -4. We're not hitting our head on it with the graph, which means that we fall into the first case, which means our horizontal asymptote was -4 on up to infinity. We need to know whether a function is increasing or decreasing. So remember, we look from left to right, and from left to right, the graph goes down. And because the graph goes down, our function is decreasing. And yes, you need to remember how to explain this. If our function goes up from left to right, it's increasing. If it goes down from left to right, it is decreasing. And we already graphed the function.